Hello everyone, I hope you're all doing very well. Today we're looking at Case 3 carrier approach and recoveries as they exist on the Supercarrier at the moment, 18th of May 2020. They may change in the future, and if they change then we'll redo this video. So I've condensed the information from the Supercarrier manual into one page, what I consider the most important things to talk about. Case 3, this instrument recovery is used at night or when the weather is below Case 2 minimums. Case 2 and Case 3 recoveries are flown from a Marshall stack behind the carrier, and this is the first thing we're going to go through. So Case 1, as you remember, we've got a video on that, flies from a Marshall stack which is based on a 0.1 on the carrier. So essentially it's a Marshall stack joining the carrier. Case 2 and Case 3 are different in that we have the stack, so this is the holding pattern before aircraft actually go in to do their final and land. Now this is offset on the reciprocal runway radial by a certain amount of miles at a certain altitude, and because of that it's dynamic. It follows the ship and depends on your altitude. So the distance of the Marshall stack from the ship is calculated thus. It is 15 nautical miles plus 1 mile per 1,000 feet of your holding altitude. So let's say you've got 6,000 feet you're assigned. So that means a total offset of 15 miles plus 6 equals 21 miles, and 9,000 is 24 miles. 15,000 is 30 miles, and so on. So that's how you calculate the distance from the carrier to the Marshall stack. So this here is a really good description of our timeline when we do things. The first thing we're going to do about 50 miles out, as with Case 1, is to call inbound. This approach starts with an inbound call to the Marshal, who will assign a holding location, holding altitude, and approach time. So we have times with this we have to worry about, as well as locations. So once we're given the Marshall stack location and our departure time, we will fly from the edge of our carrier controlled area to our newly positioned Marshall stack. At that point, aircraft will fly the Marshall stack. So aircraft will fly the Marshall pattern with 6-minute left-hand turns, 2-minute turns, and 1-minute legs. So we're going to base how we do this racetrack pattern on our speed and on time. Each flight, maximum of 2 per Case 2 and 1 per Case 3, will hold at offset patterns with 1,000 feet of separation. The lowest flight in the stack will be next. Each aircraft will generally push to the carrier from the Marshall stack at minimum intervals of 60 seconds, so we can have at least 1 minute between landings, just common sense. When we reach the Marshall stack, as we go into our racetrack pattern, we will contact ATC and say established, to let him know that we're established in the racetrack pattern. When we hit our push time, we will leave the Marshall stack towards the carrier and use ATC comms to say that we are commencing. That's so that they know we're leaving the stack for the carrier. First thing we're going to do, leaving our pattern, is descend at 4,000 feet per minute, and that sync rate is important, until we get down to 5,000 feet AGL. While doing the descent, we will do a check-in call to the ATC. There's also an approach handover at this point, but we're not going to worry too much about that. Once we reach our 5,000 feet AGL, we will ATC comms again and report platform so they know we're at this stage here. One thing I should say is that we are going to be 250 knots until we're told to go lower. So 250 knots we're going to be in the holding stack, and 250 knots then on until told otherwise. After the platform, our descent rate will lower to 2,000 feet per minute until we reach 12,000 AGL at 10 nautical miles from the carrier. At this point, we are going to configure for landing. So flaps down to full, gear down, air brake if you need it, and hook down. Then we are going to fly level. In this time, we will get down to 150 knots and work our way to on speed, maintaining 1,200 feet. We'd also be acquiring our ACLS lock if we were using ACLS. ACLS is optional on a Case 3 and will be covered in a separate video. At this point, the communication is all one way. Information will be fed to us, but we will not have to actively contact anyone until 3/4 miles. After 6 miles, we will attain on speed, so that is the correct landing angle of attack for our current weight, whatever that speed is. We're going to fly the needles, which simply means flying the ICLS needles, the glide slope and the localizer, and I've got another video on that I can link if you want. At 3 miles, this is a bit of a superfluous note here because you're flying the needles at the end of the day, but the needles will get you to 3 nautical miles at about 600 feet, and you're going to be on speed until the end of the descent. Keep flying the needles. They will take down to 375 feet at 3/4 miles, at which point, as in the Case 1 recovery, you will either A, call the ball if you've got eyes on the ball, or B, Clara. We're not going to go over that now because it's quite a lot to talk about, and we've got that clearly covered in our Case 1 tutorial. At that point, we will fly on the usual indications and verbal commands from the LSO to land again, fully covered in Case 1. It's just a waste of time to go through it all now. One thing I'd like to point out is, as of 10 miles, we have this guy here, which is the long-range laser lineup system. It is essentially a lighter laser on the back of the boat, and it will give us different colors and flash frequencies depending on our relative localizer conditions. So, for instance, if we are out in the azimuth by the left a lot, it will fast flash red, slow flash red, red, yellow, green, and so on. So what you want to be seeing is this amber yellow color, which means you're perfectly on the runway radial. Okay, let's do this step by step. Let's get some lighting on the situation because I need to see what's going on. Let's get rid of him. Let's get rid of him on our HSI, which we're going to second up here because I need it to be able to see it easily. We are going to first go to our UFC, TACAN. We want to know the TACAN, left, Alt and Bravo. We can see TACAN is 13 X-ray ICLS channel 11 on that particular carrier. So TACAN 1-3, transmit, receive, X-ray, enter, on, off until we get on, done. ICLS channel 11, enter, on, off until we get on, done. HSI, TACAN box, ICLS box, and we're going to turn our radar altimeter on. If I can remember where it is, there it is. It's essential. Unpause. Now you can see we are 53 miles away from the carrier on the TACAN at 50 miles, which we could be coming from any direction. Remember, we're going to contact the ATC for an inbound. So, comms menu. If you want to know more about the comms menu and communications, how you do this in various scenarios, please go and watch my Case 1 video where I clearly specify exactly how and why I do these comms. ATC, CVN 71 I've got there, inbound, and wait. This is her calling me. I am board number 301. She is Courage. She's the marshal. She's issuing me a Case 3 recovery. As we all know, CV1 approach. Expected final bearing is an important one, and I'm going to write that down on my notepad as 344. That is the actual radial of the angled deck on the ship, taking into account magnetic declination. These are all important things. Next, our altimeter is 29.93 inches mercury, which we can go and change. A board number again. Marshal Mothers 164 radial. So what that's saying is the reciprocal of the angled deck is 164. Now we need that 164 to be able to plot from the carrier where the Marshall stack is, bearing in mind that that is taken into account magnetic declination also, so we can use these raw numbers as they come. 21 DME, so that means the Marshall stack is going to be 21 nautical miles on 164 magnetic bearing from Mother, the carrier, at an Angels of 6 AGL, and our push time is going to be 16. That means 16 past the present hour. It's currently 19:02, as you can see, local time. So 19:16 will be our push time. That's all of the information we need to know to be able to get to the stack, employ the stack, and then get to the carrier. Let's run that through and get our reply. Automatic reply from us, just confirming. Read back. Okay, with the read back correct and everything confirmed, let's go and plot what we need to plot. So we're going to plot a course line from the carrier. Let's zoom out so we get a bit of a better fix. There's our carrier, TACAN carrier, there's us. We're going to course line up to 164, so course select 164. Enter. So that's essentially drawn a course line from the carrier along the reciprocal 164. So what we have to do now is place the dynamic point of our Marshall stack, and that's going to be along that radial at 21 miles, which we can do because we have a distance there. So next thing we're going to do is we're going to fly to Angels 6 at the interception point of that radial at 21 miles, then turn along that radial and begin a left-hand Marshall stack. So let's go and get that done. Before I forget, let's put that QNH into our altimeter with that needle there, 29.93. A good tip here for guys is to have a pen and paper ready because you'll need to write down the radial, the reciprocal, and the departure time. Okay, now we've hit 6,000 feet. We're going to level out and we'll put an autopilot on until we leave our stack. Our speed is down to the 250 knots. We're going to press the tango button for ATC, automatic throttle control, to keep us at 250 knots until we need to reduce our speed. Reaching 21 miles from the carrier, we just need to make sure we intercept our reciprocal now. We'll zoom in on here to make this a bit more achievable. And that should do the job. You can see now that we are merging with the reciprocal and we are near as damn at 21 nautical miles. What we're going to do now is take a right turn onto the radial, then begin our 1 minute leg, 2 minute turn, 1 minute leg, 2 minute turn, repeat, marshal stack until we reach 16 past the hour. At this point, as we're joining our stack, we need to say that we're established, so F2 established in the comms.
301, established Angels 6, state 3.2.
301, Roger, state 3.2.
Okay, on the reciprocal now, we're slightly offset, but I think that's going to be near enough. We've reached 24 miles out. I'm going to make a 2 minute left turn. This means that we will have to stick at this correct speed and make a certain angle of roll. That is something that we haven't actually found out what the angle of that is, so it's a missing piece of information that we still have to gain, and I'll let you know when we get that information. What I can say is it's going to be a very shallow roll and continue our barometric hold and ATC. So we know we started the turn at just past 11 past the hour. We've now turned through 90 degrees and you can see we've done just about 1 minute's worth, so it's 1 minute per 90 degrees of turn. Now completing the 180 degree turn, and as you can see on our clock on the bottom left of the HUD, which I should have pointed out, that's taken exactly 2 minutes. Now we're going to level out on our runway radial, which is 344 magnetic, and hold for 1 minute, so until 14 past the hour. Okay, we've completed our 1 minute at 250 knots. We're going to now take a left 2 minute turn. So again, that is 1 minute per 90 degrees of turn. Back onto the reciprocal. Just be talking to my guys on the stream, and they say you don't have to fly at 250 at this point, and I'd agree, the user manual agrees with that, but I'm just using 250 to keep it all simple. So we've done another minute, we've turned another 90 degrees, and let's turn another 90 degrees. Okay, it's all coming now. We're about to hit 16 past the hour, which is our push time. At that point, we're going to left pull, expedite, cut the stack, and at that point, our speed limit is indeed set to 250 knots. You can see we're just merging with reciprocal again. Okay, so it's 16 past the hour. We need to make a commencing call, so F3 in this case.
301, commencing, state 2.6.
Expedite turn.
29.93.
301, radar contact.
Maintain altitude.
Expect final bearing 3.
So she's got our radar distance and
301, switch approach.
the radial of the runway. Our next job is to obviously turn towards the carrier. We're going to get on the track onto the runway radial, and once we're level, we're going to decrease altitude at 4,000 feet per minute. Stand by. So now we're turned in towards a radial intercept, as you can see there. We're now going to dive at 4,000 feet per minute as measured there until we hit the 5,000 feet we're supposed to hit before we make our next call. We do have the speed limit now of 250, so let's go. Once we pass the 21 nautical miles, you can see that we've got a switch approach. Now what we can do on this leg, or sorry, what we have to do on this leg now is check in. So we're going to check in with the F2, and we're also going to level out once we get to 5,000 feet, because I'm slightly ahead of myself here.
301, checking in, 21 miles. 301, approach, 344.
And what we do once we hit the 5,000 deck is we make our next call, which is going to be platform. So they know I'm at 5,000 feet. So we're going to make that call now.
301.
Platform.
301. Platform. 301. Roger.
Okay, we're now going to change our vertical velocity here to 2,000 feet per minute descent. And at 10 miles, we should be at 1,200 feet AGL with a speed of 250. So let's make that happen. All the time checking our course, because we've got to merge with that radial, of course. So 900, 1,000, a little bit low, There we go, 2,000 feet per minute. Azimuth looks okay for now. So we want to hit that 1,200 feet there as our TACAN reads 10 miles. That would be ideal. In case I haven't mentioned before, in terms of azimuth guidance, we've got this graphic here. We've also got radial guidance here, course guidance here, that we've covered in other videos. Zoom in on our HSI now, just to get a little more accuracy. 12 miles to go. Okay, so that's leveled out at 1,200. Slightly under, let's neutralise that, and we're at 10 miles as desired. So at this point we need to get our plane configured, so that it's going to be gear down, it's going to be flaps fully down, it's going to be hook down, it's going to be trim to suit, and get to a speed of about 150 when we reach 6 miles out, while maintaining our 1,200 feet. So let's get that done. We're going to go gear out, flaps fully down, hook down, and it's going to mess our trim up here, so we need to do what we need to do. We're also going to come off the gas, so ATC off, air brake out to expedite, drifted off course, so let's get back on course, drifted above, so let's get back down. This bit's always a little bit ugly, obviously. Okay, got the 150, 8 miles, still haven't merged with the radial, going to expedite that just a touch. A little fast. Okay, we're at 1,200 and 150. Just waiting for 6 miles now. Almost at our radial now, not quite. Zoom in for extra accuracy. A horrible tendency to turn right. Slightly below 1,200. Let's fix that. Don't worry about that. Okay, we're at the 6 miles now. So now we're going to fly all the way to the 3/4 mile mark on the needles. So because we had our ICLS set up, you can see we obviously had our localizer, azimuth indicator, and our glide slope elevation indicator. We're going to fly essentially so that our localizer and our glide slope are going to be both pinned in the middle of our velocity vector, with the E bracket here pinned in the velocity vector to ensure that we are on speed all the way down till the carrier. And the next thing that we do other than that is to make our ball call at 3/4 mile, or our chloracall. Otherwise it's going to be pretty similar to case 1 landing. So let's see how we go with that. Okay, so off we go. So the localizer wants us left a little, which is fine. So we've got to get on speed now as well, so that's going to be a big change to our flight characteristics. Let's get us set up for that. Plenty of trim going in. Too slow. Too slow again. Okay. I am a little low, but just sorting my trim out still. Azimuth's looking pretty good.
Altitude's fine.
Take a cheeky look down on our display. I like to use that. It helps me visualise. 3 miles, 3.7 miles. Looks like it's going to be about 125 knots for our on-speed angle of attack that we want to maintain. Okay, our localizer is correcting to the middle, so let's allow that to merge with the middle. Looking at the laser on the back of the carrier, you can see I'm orange now, so I'm on azimuth, I'm on radial. I've got the ball. I'm not actually on it at the moment. I may be so far down, maybe. I wonder. I'm not actually on it, but we'll see.
We are.
That's not a problem. Yeah, I am low, and that's fine, because that will self-correct on my current attitude. Quick check around the cockpit, just make sure everything's down. It does appear to be. Right, it's all hard work from now on. Our E-bracket in the centre, our localizer in the centre, our glide slope in the centre. We've Gone off course, we're solid red. So let's work to get back on course. We're bang on the ball. Velocity vector onto the wires. Looking for our 3/4 ball, mile for our ball call. Here we go. Pulling the ball now.
301, waterfall, 1.4.
I'm a little high here, so I just need to correct. Try and correct with trim, but I'm finding stick just a little bit necessary. Okay, that's pretty good. Okay, now that's just hit those wires, hit those wires, hit those wires. The annoying thing is you can't see the bloody things, but let's hope for the best. Full power, power off, release brake, hook up, and that's us done. Not perfect, I'll admit, but not bad for a second go. A Case 3 demonstration in a Hornet. Obviously the other option is we use ACLS, which we can do at the moment with the Tomcat, but I wanted to show the Hornet because that's what most of you drive. I hope that was useful, and I'll see you later.